Superstructure. You referred to a twin wall stud system. I just wanted you to spell out what that is.
Twin wall stud system. What is a twin wall stud system? It is actually what it says. It's just two different stud walls put together, but it will be constructed in some way. There will be ply gussets or something holding that together, sometimes a metal bracket, but it's basically two stud walls put together with a board one side of each, here and here for racking, and then there will be a noggin or a frame or a gusset or something nailed to that on occasion to hold that together. Twin wall studs, just simply two layers of stud work.
Excellent. So we'll be able to share a bit more detail about our twin wall stud system that we've got in the workshop. And
we've got an I-beam system.
Yeah.
Which is
that.
Yeah, that's why I put that on there. This is an I-beam system. We don't use a twin wall stud system. It's different. So the I-beam system, this is an I-beam system, which basically means there's two pieces of timber joined together with a OSB or a boarding in between to form a solid stud. So it's not a twin wall system, it's an I-beam system. Same principle, but we have a solid board in between instead of just an occasional fixing.
Excellent. So it's the actual I-beam that makes it different.
The I-beam makes it different.
Yeah. So on this image here, you referred to the insulation internally and externally as well. So I'm assuming that they're smaller amounts of insulation versus the I-beam system there that's got, well, I'm going to assume about 300 mil.
Absolutely.
You'll have different.
Yeah, what we've got, the I-beam system here, we'll have 300 mil of depth there, 300 mil of insulation. These are just examples. These aren't to scale. These could be a lot wider. You know, this could be, I'm assuming this would be a 300 mil continuous or overall size, the same as that. Now this one is this is probably at least 225 mil thickness of insulation. But because we've got a structural board inside and out, but no additional insulation, there is a potential there for a cold bridge or thermal bridge. Here, we've got a continuous insulation, which has been fixed through with a counter batten, which is basically an external batten just screwed through into the stud, but the insulation is pretty continuous. This is the more effective one, which is the twin or the split insulation, where we've got a stud work, insulation in between, structural board, and then an external insulation put on to eliminate any cold bridge and to thicken up and to bring a more of an insulation to that wall.
So why would you have a split insulation system?
It would depend really on your design. If you've got a retrofit system, sometimes external walls are actually stud work. And you could fill them full of insulation, external insulation underneath. Sometimes structurally the timber is all you need. So we're added an additional insulation on the outside to cancel out any cold or thermal bridge. Because potentially if this is for outside like here, this is a potential thermal bridge. They've compensated for this by going wider and offering more resistance over a given amount of distance. Here is smaller. So what they've done is this thermal bridge here has been cancelled out by this bit of insulation on the outside. So they're forming like T's of insulation. So it's more thermally efficient.